So for section 4.4, we're going to be talking about solving exponential and logarithmic equations, and we're going to kind of break this down, several videos kind of covering each type in its own video. So we're going to be starting with the exponential side of this, and for exponentials, there are two options for how to solve these. One option is going to be that they involve getting the same base, and the other one is going to be that when we can't get them to go to the same base, that we are going to use a log or use logarithms to help us solve it. So first thing is, for the same basis, the concept is if I have 4 to the x equals 4 squared. The concept here is if we're trying to figure out what x has to have a value of here, we're kind of matching parts and pieces. They both have a base of 4 and we have the equal sign. So then the x and the 2 must also be equivalent. So then x has to be 2. So breaking that down and putting it into our math notation, if I have b to the m equals b to the n, again, having the same base, then m has to equal n. Now, in some scenarios, you'll already be able to see that they have matched bases, and it's fairly straightforward. In some of these, we are going to have to rewrite the bases in order to get them to match. Now, one thing of note here is, generally, you will take larger bases and try and break them down to something smaller if you see something smaller. We don't really take small things and send them up higher, okay? So, for example, looking at this first one, we've got 5 to the 3x minus 6 equals 125. So I'm going to swap over to our whiteboard. Okay, so here's what we've got. Now, what I was talking about here is we're not going to send 5 up to try and get to 125. We want to try and take this 125 and bring it down so that it matches and has a base of 5. So we start thinking about powers of 5. So 5 to the first is 5. 5 squared is 25. 5 cubed will be 5 times 5, which is 25, times 5, which is 125. So 125 can be rewritten as 5 cubed. Okay, so now we've got the 5 and the 5 match. So we can, in essence, cross off those bases. So now I have 3x minus 6 equals 3. So I'm pulling the power here and the power there. So now this is just the traditional solve. So I'm going to move my 6. So I've got 3x equals 9. I'll divide by 3. I've got x equals 3. And again, we can check this back in. 3 times 3 is 9. 6 is 3. 5 cubed is 125. So we do have that will process through. Now, sometimes you may have to change both bases and bring them both down. So let's take a look at an example of that. So I already talked about that we take larger bases and try and bring them down. But if I think about powers of 4, 4 to the first is 4, 4 squared is 16. We bypass the 8. So we start thinking about, is there a base smaller than 8 and smaller than 4 that I can get to both of those? And so our thought becomes 2. If I do 2 squared, that gets me 4, and then 2 cubed is 8. So what we're going to do here is we're going to rewrite the 8 as 2 cubed, and then what was up here already, we're going to put into a set of parentheses to show that that was already up there all grouped up together. And I'll do the same thing over here. So we've got 2 squared. And again, I'm going to put what was up there in a set of parentheses so that it's there. Now we have those matched bases. So we can clear off those matched bases. So I've got 3, and I'm still going to keep all of this coming down. Now, you can go ahead and distribute as you come down, but I'm going to show just where I brought them down. Then we'll distribute. And now I'm going to work on getting things pulled to one side. So I'm going to move my 2x this way. And then I'll subtract 6. So I get negative 12 for that answer. So you've now seen 3. The first one that we did was kind of on that example slide. 4 and 4, they already had matched bases. The second example that we looked at, one side needed to be changed and altered to get them to match bases. And then in this example, we had to change both sides down. In the next video, we will be looking at still exponential equations, but what to do when we can't get those bases to match.